Hello and welcome to another session in mathematics. In this session we'll be looking at trigonometric ratios. But before that, let us look at the previous lesson. Welcome back. In this lesson we'll be looking at the sine, cosine and tangent of acute angles. Sine, cosine and tangent of acute angles. Okay, let us start with the definition of this word acute angles. What are acute angles? Acute angles are angles measuring less than 90 degrees. They are called what? Acute angles. And we want to look at some special angles that are less than 90, and we take their sine, cosine and tangent, and then we use them to solve some problems. Okay, assuming we have a right angle triangle of the form ABC. Remember, here is our angle 90. Okay, and here is our theta. Now here is a small letter C, here is a small letter A, and this is a small letter B. Generally, when we talk about trigonometry, we talk of sine theta, cos theta and tan theta. Okay, and there's an acronym we use in determining the side of all these angles, and that is what we call SOHCAHTOA. And so here simply means sine, and it tells us that sine is equal to opposite over hypotenuse, where ka means cosine and cosine is adjacent over hypotenuse, where tua means what? Tangent, which is opposite over adjacent. Okay, now in this triangle, the hypotenuse is the highest line, and it is the line facing the angle 90. Okay, we call this what? The hypotenuse is the longest side, the line facing what? Angle 90. We call it the hypotenuse, and the line facing the given theta is what we call the opposite. The line facing the given theta is the opposite. Mark that. The line facing the given theta, opposite, and then the last line is what we call the adjacent. Okay, now it invariably means that sine theta is equal to B over what? A, since B is opposite and A is what? Hypotenuse. So when we talk about sine theta, we are looking at what? B over A. Okay, then for cos theta, it's adjacent over hypotenuse, and our adjacent is C, hypotenuse is A, so we have what? C over A. Okay, and then for our tan theta is equal to opposite over adjacent, and our opposite is B, adjacent is what? Is C, so we have B over C. Okay, I want you to note these three things because they'll be beneficial to us even as we solve problems in trigonometric ratios. Okay, now I want us to take some examples in this part of trigonometry that has to do with acute angles. Okay, we have the first question on the screen. It says a triangle has sides 8 cm and 5 cm and an angle of what? 90 degrees between them, and the question is, calculate the smallest angle of the triangle. Calculate the smallest angle of the triangle. Okay, the question then will be, how do we determine the smallest angle, or which angle is the smallest angle in a given triangle? Okay, the first thing we need to do is to draw this triangle. Okay, we have this right angle triangle where this is our angle 90, and this is our given theta. Okay, now we have this to be 5 cm, and we have this to be 8 cm. Okay, now the question said we should find what? The smallest angle of this triangle. Now, looking at the diagram on the screen, you agree with me that what we use here is tan theta, since the hypotenuse is not given. Remember, I told us that the hypotenuse is the line facing what? Angle 90, and here it is not given, but our opposite is given and our adjacent is given. So it simply means that what we use in solving is what? Tan theta, since tan theta is equal to what? Opposite over adjacent. And I told us in our last in the previous explanation I made that our opposite is the line facing the given what? Theta. So this is the theta. The line facing theta is 8 cm. Is that correct? And our adjacent is what? Is 5 cm. Okay, now that is to say that tan theta is equal to 8 over 5. Okay, and when you divide that, you have 1.600. Okay, now we are looking for the value of theta. Okay, so tan theta is equal to 1.600, making theta the subject of formula. We then have theta to be equal to tan crossing over becomes a negative tan, and we call it tan inverse, not minus tan. Okay, we call it tan inverse of 1.600. Okay, how do we press this in the calculator? You press this by pressing shift tan. Okay, in your scientific calculator, the first thing you do is to press shift. Then when you press shift, you now press tan. It will appear tan raised to power minus 1 on the screen, and then you add 1.6, and when you do that, you have that theta is equal to what? 58 degrees. Is that correct? Yeah. So now we are looking at the third angle in this triangle. Remember, a right angle triangle is a triangle whose highest angle is 180. Let me say it again. The total angle in a right angle triangle is 180. Okay, so theta here is 58 and this is 90. So we are meant to find what? The value of this. And how do we do that? We'll say that 180 degree minus 90 plus 58 will then give us the value of this. Okay, so we have 180 minus 50 plus 90 will give us 100 and what? 48. And 180 minus 148 will give us 32 degrees. Okay, so the smallest angle in this triangle is what? Is 32 degrees, because 58 is higher than 32. So the smallest angle is the angle what? 32 degrees. Okay, let's take one more example before we can call it a day. Okay, number 2, we have question number 2 on the screen. It says in the figure below, LK is perpendicular to MN. Calculate the angle at N in triangle what? MNL. Calculate the angle at where? N, the angle here. Okay, that's the angle we are to solve in this triangle MNL. Okay, so let us start. Looking at the triangle LMN, you agree with me that you cannot solve for this line because it is 2 in 1. So therefore, all we need to do is to bisect this triangle and then take this angle first, solve for the line LK, and then if we can obtain the value of LK, then we can solve for LKN. Okay, So we need to solve for what? Line LK. Okay, line LK, which is this. If we can solve for this, then we'll be able to obtain the angle at what? N. So let us start. We'll bisect this angle, and then we'll have something like this, a right angle triangle. This is our angle 90, this is our angle 70 degree, and here is our M, here is our K, and here is our L. Here is 7 cm. Remember, the angle we are dealing with is this. Okay, now looking at this, what do we do in this triangle too? You will agree with me that line LK all over 7 cm is equal to sine 70 degrees. Is it correct? Okay, we are looking at the angle at M, and then we are looking at 7 cm. 7 cm is our what? Hypotenuse in this triangle, since it is the line facing what? Angle 90. Is that correct? And our sine always makes use of what? Opposite over hypotenuse. Is that correct? So opposite over hypotenuse, and our opposite here is the line facing the given theta, the given angle. Okay, our given theta here is angle 70 degrees, so our opposite is the line facing angle 70. Therefore, line opposite over hypotenuse is equal to sine theta. Okay, now we have our hypotenuse to be 7 cm, and we have our theta to be what? 70 degrees. Do we now understand? Fine. So making LK the subject of formula, we have that line LK would then be equal to 7 times sine 70. Okay, then LK would then be equal to 7 times you press sine 70 on your calculator, and that will give us 0.9397. Are we following? Okay, now 7 times this will give us 6.5779 cm. So our line LK is equal to what? 6.5779. So we found the value of this to be 6.5779 cm. Okay, now we are looking for the angle at N, remember. So we now need to solve for this remaining angle LKN. So let's go over to the next page as we draw it. We have something like this. Here is our angle 90, and here is our K, here is our L, here is our L. Okay, now the line here is 6.5779, and the line here is 21 cm. Here is unknown, and we now solve for the angle at N. Okay, so what do we do now? Let us start. We have LK to be equal to, remember what we are using is sine theta. This is the theta. Okay, so the angle, the line facing this angle is opposite, and this is our opposite, and this is our what? Hypotenuse. Okay, so we are using sine theta. LK over, remember this is our LK over LN will then be equal to sine theta. Okay, our line LK is what? 6.5779 all over our LN is the line 21 cm to be equal to sine you can call it theta, since we denoted it with what? Theta. Okay, so 6.5779 divided by 21, what do we have? We have what? 0.3132 to be equal to sine theta. Okay, now since this is theta, what do we need to do? We need to find the value of theta and not sine theta. So the value of theta would then be equal to sine inverse, that is sine crossing over the equality sign becomes a negative sign, so sine inverse of 0.3132. Remember how we press that? You press shift sign to give you sine inverse. So press shift sign of 0.3132. Therefore theta will give us what? 18.290. okay, and we need to approximate that to give us 18.3 degrees. Okay, so the angle of this triangle at L and K is equal to what? 18.3 degrees. Okay, to refresh your memory of what we've done so far, take the test on the screen. Welcome back. So far we've been able to look at the introductory part of trigonometric ratio, and we've been able to cover trigonometric ratio of an acute angle, and then we've taken some examples to explain that the more. So we'll stop here for today, and we'll continue in our next class with determination of length of chords using trigonometric ratios. So do well to use the lesson note on the platform for better information on the topic we've just discussed, and feel free to drop your questions or comments on the comment section. Till we meet again in our next class, stay safe and bye.